Welcome back to the channel. Today on the operating table, we have a MacBook A2338. It just came in for repair. Let's see if we could fix it. Let's begin. All right, so what's the story behind this one? The customer just left my place and he's saying that he thinks his daughter may have dropped some water, some sort of liquid on the keyboard, and it caused the laptop to short out. So I'm not going to plug anything in since that we already know that it might be liquid damage. But if you're new here, at the very top here, we have my multimeter, and this is gonna be my power supply. But I think I'm just gonna go ahead right now and just open up the laptop and see what we find inside. All right, just looking at it with the naked eye, I am not really seeing anything that stands out. Everything looks pretty clean, but let's go under the microscope and let's take a look and see what's going on. Let's head around the board and see if we could spot this liquid damage that's suspected. Yeah, I don't see any liquid damage on the front of this laptop here, which makes sense though, because the keyboard is on the other side, so I would expect it on the back of the laptop. Let's go ahead and plug it in and see what's going on here. All right, so keep an eye on the power at the very top here. So we have 19 volts. That's what we're looking for. And let's see what happens here. We're plugging it in, and it's going to 5 volts, 19 volts. It's flashing on and off. And you can see that we're not getting any communication with the USB-C controllers. So something is definitely flashing on and off. So let's see what's flashing on and off. Let me get the thermal camera out here. Let's go straight to the thermal camera. All right, so I've already troubleshot this a little further off camera, but I just wanted to show you guys one of the techniques that I use, especially when you have something like this. Whenever the voltage is flashing from 5 volts to 19 volts like this, something is trying to come on. Up a power rail, something is trying to turn on, but it's being pulled back down. So one of the techniques is just basically just go straight to a thermal camera, because you're going to see something on the motherboard that's going to be pulsing. So I'm going to see if you guys can spot it here. I already know where it is, but see if you guys can spot what the issue is. I'm just going to go slowly over the board here. You see that? It's pretty simple to see it now, right? Right there. See that flashing on and off? And if we pull that under the camera here, you can see it's an inductor. Okay? So I've already gone a little further. This is as far as I've gone. I've checked the inductor, and there is a dead short on this inductor. I just wanted to show you a bit of a technique on just how I use the thermal camera in a situation like this, right? So let's go ahead and continue from where I left off. All right, so this is where I've left off so far. And if you keep an eye on the multimeter at the top there, I'm just in diode mode here, and I just check right here. You'll see right there, we are dead short. Okay, now let's pull up the schematics and see what we're dealing with, which voltage rail this is, and where this is tying off to. Okay, so let's jump into where that inductor was, and I believe it was right here. So you can see that it's something on the PP3V3 power rail, and this is where our short is. So what I'm going to do is I'm going to go ahead and inject voltage in here now. Now that we know this is the short, I'm going to go ahead and inject voltage in here, and let's monitor it again under the thermal camera, because the first time was just giving us the rail that was hot, because it was anything on that rail could have gone hot, but in this case this inductor did, right? So we're just going to inject voltage into the inductor to actually find where the short is. Okay, so let's go ahead and do that. All right, so let's get the injection going here. So you see on this camera to the right here, I'm going to be injecting at 1 volt. And 2.5 amps is my threshold. Remember, this is a dead short, so I don't have to go with high voltage injection here. Plus, you don't want to be injecting high voltage anyway. into your laptop. If you had like, let's say, a 30 ohm, 40 ohm short, yeah, injecting 1 volt's literally not going to do nothing. You're not even going to see it probably, right? But in this situation here, we almost had a dead short. So 1 volt is probably all we really need in this situation. So let's go ahead and inject right on this inductor. Let me see, where was that inductor again? It was right here. So let's get on that inductor and let's see what gets hot here. And I'm not seeing anything there. Let's just, we're taking 2.1 amp draw and I'm not seeing anything getting hot. Oh, this entire area is hot, or is that just reflection? That's not reflection. See, there's a circle, kind of like a halo right here. That's reflection, but I don't think this is reflection down here. All right, let's try that again. Let's inject and let's keep an eye on this area right here. So where's my inductor? Right here. Yeah, right there. See, this entire area is getting hot, but there's nothing there. So obviously it's on the other side of the board. Yeah, this entire area is getting hot. Whatever the fault is, it's on the other side of the board, which makes sense because the customer said that his daughter suspected that it's dropped liquid. On this side of the board, we see no signs of liquid damage. But that would make sense because it would go through on the keyboard, which is the back side of the motherboard. So give me a minute to take out this entire motherboard and we'll see what's going on. All right, so I have the motherboard out. And this is where we were injecting right here. And remember, the heat source was coming right here. So if we flip the board, not good. That is our Wi-Fi chip, right? So I'm pretty sure we're going to see something around here. Yeah, but since the entire area was getting hot, I'm pretty sure it's the Wi-Fi chip that is taking the brunt of this liquid damage. Let's go under the microscope. Okay, so going under the microscope, you can see right here that we do have damage right here. So it looks like the liquid fell here and then rolled off onto this capacitor. If I zoom in a little better, yeah, you can see where the liquid fell, rolled off. You can see the corrosion on this capacitor right here. So let me grab my multimeter. Let's check on this side. And we're at 0. And this side, we are also at 0. Yeah, we're on 0 both sides. Let me just double check the schematics here. So yeah, so the left side was ground, and this is our PP3V3 right here. So not looking good. If I remember correctly, with this particular chip, this is tied to the M1 security. So you are pretty much euchred unless you can, yeah, you're pretty much euchred. Yeah, you can't just take this chip off another board and slap it in and it'll work. It's tied to the CPU. Okay, so just to make sure, I'm just going to inject some voltage here just to make sure. It'd be nice if it was a capacitor or something around it, but I doubt that's going to be the case. Let me just lower my voltage because I'm so close to this thing now. Let's go down to like 0.7 volts. And let me just come with power on the test point here. And let's see what gets hot. So here's the test point right here. And I'm drawing nothing. What am I drawing? Oh, it helps if you use your right leads. I was using my multimeter leads. All right, so let's come with ground right here, and then power is right here. No way. It looks like it might be the cap. You got to be kidding me. Look at that. You have got to be kidding me. Okay, let me try that again. I just moved it out of focus here because I got so excited. Let me see here. There's no way. It looks like it's the capacitor that's bad. That is wild. All right, let's go ahead and remove that capacitor and see if it clears our short. All right, so let me try to clean it up first for you guys here. Let me try to get rid of some of this underfill. All right, what do you think? The short is gone? What do you think? Is this going to be a lucky customer today? Let's take a look and see. Where's my multimeter? And we're testing on the test point right here. And we are 0.3 voltage drop. What a lucky customer. So let's go ahead and put this capacitor back in, and we'll do another test. And I think the board should fire up. All right, so the capacitor is replaced, and I'm expecting the same here, obviously. Yep, we got 0.36, right? So let's cross our fingers and let's hope. I was so excited about getting to see if this thing was working that I actually forgot to hit record, but I'm glad to say it is working. So I just have just the power plugged in here. Everything else is pretty much disconnected here. I never put everything back in because you'll put everything back in and your problem won't be fixed and you'll take everything back out, right? So, but in this case, just wanted to show you guys here, plugging it in, and you can see we're no longer flashing from, back from 19 to 5 volts, and our amp draw is perfect. And there you go. We have the Apple logo, and we'll just wait for it to boot into the OS here. The Mac OS should be coming up soon. And there you go. Perfect. We are back in business. All right, I got the computer all back together now, and talk about a lucky customer. I was not expecting, when I saw that massive heat signature coming from the back of the board, it wasn't like a solid, small circle. It was spread out. So I thought for sure the Wi-Fi chip was gone. I was already ready to tell him that, that the MacBook's going to work, but with no Wi-Fi. But I'm glad it was able to be repaired. Thank you for watching, and I'll see you on the next video. Bye for now.